offer. Hey budding charms, what are you waiting for? So we have come up with 50% off on our CBSE subscriptions. So you can make use of it, and this is the best time to go for this deal and make use of the code UNLOCK, and this is valid till October 12th. So please don't miss it. This is going to be a super amazing offer during festive season. Hello budding charms, welcome back to our very first one-shot session on the topic called light. So this is going to be a super simple session, but we have a lot of things to learn. So please pay attention throughout the class and try to take down the important points. Not only that, please have a notebook and a pen so that you can write down the important points. And if you find any kind of doubts in between, please don't hesitate to put your doubts in the comment box, because I will help you out. And my name is Aishwarya Sindhu Ramachandran and I will be your science educator today. So let's dive into a session, and here you can see that light is a bliss. Do you think so? Yes, of course. So without light, nothing can be seen. Without light, there are a lot of things get interrupted, right, in our day-to-day lives. So it's very important to have light in our life. So now we are moving towards the contents. So for the easy understanding, I have made this particular chapter into two sections, and here's the part one, and in this one we will be learning laws of reflection, types of reflection, image on a plane mirror, image types, and finally dispersion. So these are the basic things that we will be learning in this particular part. So let's get into the first part of it. And what is it? How do we see objects? Oh, that's an important question, right? For example, if I want to see this particular pen, there must be light, right? Imagine if there is no light in this room, then what happens? I will not be able to see this pen for sure, right? So that's the same thing we need to understand, that there must be a light source. So in this scenario, I have considered sun as a light source. Okay, so there must be a light source, and from the light source, the light has to fall onto the object. So here the plant is considered as our object. So you have to be very, very clear with these terms. Look at this. From the object, the light needs to reach our eyes. So this is how we are able to see an object here. Clear? So from the sun to the object, from the object to the person. So this is how we are able to see the things. So, and that's where we need to understand what reflection is. So here is what we are going to learn is all about reflection. So let's get into the next one. It's all about reflection. So what is meant by reflection? So for that you need to have a surface. So when light falls onto the surface, it bounces off back to the same medium. Oh, that's an amazing thing, right? So we have a surface, the light ray falls onto it, and once it strikes, it just bounces off back to the same medium, and this is called reflection. So you have to be very, very clear about this particular phenomenon. Why? Because without reflection, nothing can be seen. So for that, I have just made a small picture for you, and you can see that your mirror has considered as our surface, and the light ray which falls onto the surface can be called it as, what is that? Can anybody tell me? So if you look at this picture, the light ray which falls onto the surface can be called it as incident ray IR. Got it? And this strikes on the point called POI, point of incidence. Then what happens to the reflected ray? Yes, it bounces off to the medium. Which medium? To the same medium. So bounces off back to the same medium, and therefore this ray can be called it as reflected ray. So the ray which bounces off back to the same medium can be called it as reflected ray. So there is a dotted line which is perpendicular to the surface itself. What is this dotted line? It's nothing but the normal can be represented with letter N. So normal is nothing but an imaginary line which is perpendicular to the surface itself. Clear? So we know what is incident ray, what is reflected ray, and what is normal. And now we are going to learn something very important. What is that? angle of incidence and angle of reflection. So that's what we are going to learn now. So then I'm going to change the color once. So the angle between incident ray and the normal can be called it as angle of incidence. Similarly, I have to take a different color for representing the angle of reflection. The angle between reflected ray and the normal. So that's nothing but the angle of reflection. Clear? And when you look at this, you can understand that the angle of incidence is equal to angle of reflection. Very, very important. So please keep this particular one in your mind because we are going to continue with the same thing in the next part. So now we are getting into the part of types. So here we can see that there are mainly two types of reflection. What are they? Regular reflection and irregular reflection. And here we are going to learn the basic differences between them. And look at it. What is it all about? It's all about the difference between regular and irregular reflection. So let me tell you about regular reflection first. So when you consider regular reflection, this happens from a very smooth surface. It happens from a smooth surface. Then, what is happening here? Look at the incident rays. Oh, these are the incident rays. And it strikes on the surface. Then, it bounces off back to the same medium. So, these are the reflected rays. But when you look at these reflected rays, you must have to understand that these are parallel to each other. Am I right or not? Yes. So, the reflected rays are parallel because it got reflected from a very smooth surface. Then what could be the image type? The image is going to be clear and sharp. Please understand, the image is going to be very clear and sharp. And the reflected rays are parallel. What is example here? Reflection on a plane mirror, which creates a sharp image because it is happening from a very smooth polished surface called mirror. And what about irregular reflection? Oh, that is nothing but happening from a rough surface. What is meant by rough surface? The surface has a lot of irregularities like this. It is not smooth, right? So this is happening from a rough surface. So look at the incident rays. Yes, these are the incident rays. And what about the reflected rays? These are the reflected rays. And are they parallel? No, they are not parallel to each other, right? So that means it is going to create a blurry image. Sometimes no image will be formed. Clear? So the reflected rays are not parallel. That is what the reason we took an example of reflection on water which creates an irregular shaped moon. So it is happening from a rough surface. Therefore, the image can be blurry or it cannot be formed. So these are the two possibilities, and there is one more information for you. Irregular reflection can also be called it as diffused reflection. So irregular reflection has a different name. It's nothing but diffused reflection. And now we are moving towards the next one. It's all about laws of reflection. Very, very important. So what is meant by this law of reflection? Whether it is diffused, whether it is regular reflection, whatever it is, if reflection has to happen, it must be obeying the law of reflection. So it is applicable to both diffused and regular reflection. Clear? So now let's learn the two statements of it. So I know what is incident ray, what is reflected ray, what is normal, what is angle of incidence, what is angle of reflection. We know everything about it. So let me rewrite it for you. So this is incident ray. So you have to be very, very clear with the arrows because it may make you wrong. So you have to be very specific with the arrow marks that you give. Then we have normal here, the angle between incident ray and the normal can be called it as angle of incidence. The angle between reflected ray and the normal can be called it as angle of reflection. So we know all the terms related to it. But what is the first statement? The angle of incidence is equal to angle of reflection. So we know that statement already. So angle of incidence is equal to angle of reflection. Got it? Similarly, what is the next one? The incident ray, reflected ray and the normal at the point of incidence all lie in the same plane. Oh, that is a bit confusing, right? Don't worry at all. Let me break it down for you. So here we are going to find the vertical plane. So look at it, I am considering a vertical plane here. Incident ray, normal, reflected ray at the point of incidence all lie in the same plane. So the same plane has been marked with red dotted lines here. Look at it, this is a vertical plane I meant. Okay. So I hope you are clear with the point, and now we are moving towards the next one. And look at it, it's all about images. Oh, there are two types of images. What are they? Real images and virtual images. So when you talk about real images, these are basically formed due to the actual convergence of light rays. So the light rays actually converge and create real images. Therefore, this can be seen on a screen. Very, very important. Okay. For example, in a cinema theater, okay, you see that there is a screen, and on that screen we are able to see the image. Why? Because it is a real image, because the light rays converge and therefore real images are formed. But what about virtual images? These are formed due to the apparent convergence of diverging light rays. You have to be very clear with the terms. Convergence. What is converging here? Apparent convergence of diverging light rays, so that virtual images are formed. What does it mean by that? It's nothing but they are not actually meeting each other. Okay, they are not actually converging each other, and therefore the images formed here can be called it as virtual images, and therefore this cannot be taken on a screen. Clear? So real images can be taken on a screen and virtual images cannot be taken on a screen. So let's take an example of a virtual image. The image that is formed on a plane mirror. It is a virtual image. Clear? I hope everyone is clear with it. Shall we move on to the next one? Yes. So now we are going to talk about image formation in a plane mirror. So for that I have to consider an object. Look at it. This boy is nothing but our object is. Okay. So now I need to get the image of the object. Image. So if you want to create an image, a minimum of 2 rays must be considered. Okay. Minimum of 2 light rays must be considered to get an image. So let's take the first ray and the second ray. So once they hit on the mirror, they get reflected, right? Yes. So you can see that this is the way they get reflected. But where does the image form? Oh, so for that I have to trace it back, and this is where the image has formed. So from this we can understand that on a plane mirror the image formed is virtual. Okay, because they are not converging actually. Okay, there is no real convergence. That is what the reason we are tracing it backwards, and therefore we are able to generate a virtual image here. Got it? I hope everyone is clear. Shall we move on to the next one? Yes. So now let's learn the basic characteristics of an image formed on a plane mirror. Erect. What is meant by an erect image? Oh, that means it's upright, right? It's an upright image. Okay, that means it's not inverted. Okay, it is always upright. Okay, and same size. What is meant by that? If Arun has 150 centimeter height, then Arun's image is also going to have 150 centimeter height. And similarly, it is virtual. That means it cannot be taken on a screen, right? And lateral inversion. What is that? This is a phenomenon which is happening on the plane mirror. If you raise your left hand, it shows as your right hand. If you raise your right hand, it shows as your left hand. So this is nothing but the lateral inversion is. Then the very, very important point. The object distance is equal to image distance. What is meant by that? Oh, so let me break it down for you. So this is a mirror. Okay. So this is an object and this is the image. Okay, so let's see the distance between mirror and the object. 5 meters. Similarly, if you look at the distance between mirror and the image, oh, that is also 5 meters. Very, very, very simple. Clear? So I hope everyone is clear with the point. And now we are moving towards the next one. It's all about multiple reflections. Oh, where do we apply? Kaleidoscope, right? So you might have seen kaleidoscope in your day-to-day lives, right? So it creates different kinds of patterns when you look into it. Why? It's because of the multiple reflections. So when two mirrors incline each other, it creates multiple images due to multiple reflections. So if you are able to see multiple images, then you have to understand that there are multiple reflections happening. Similarly, if an object places between two parallel mirrors, infinite number of images are formed. Infinite. That means there are many images which are forming here. And to calculate the number of images formed by the plane mirrors, you have to use this particular formula. N is nothing but the number of images. That is equal to 360 degree divided by theta minus 1. So 360 degree divided by theta. So theta is the angle between the mirrors. And that has to be taken there. Then minus 1. So 360 degree divided by theta angle minus 1 is a formula to find out the number of images formed. Clear? So this is a formula that you need to use, and now we are moving towards dispersion of light. Very important. Okay. So in this case, I'm going to tell you what is meant by dispersion first. Okay. So what is meant by dispersion? Splitting of white light into 7 component colors. Very simple. But when it is happening? When it passes through a prism. Got it? So when sunlight or white light passes through a prism, it splits into 7 component colors, and this is called dispersion. And this is what the same principle behind rainbow formation. But in the sky, we don't have any kind of prisms, right? Then what is happening there? Instead of prisms, we have tiny water droplets. So through each tiny water droplet, the dispersion is happening, and therefore the rainbows are formed. Got the point? Okay. So let me tell you how this is actually happening right inside a water droplet. So for that, I have to consider 3 surfaces of the droplet. So this is the first surface, this is a second surface, this is a third surface. So in the first surface, the white light from the sun enters into the water droplet. So that means it is changing its medium from air to water. Clear? So if it changes its medium from air to water, what is the process happening there? It is refraction. Okay. So refraction is happening. Clear? Because it is changing its medium from air to water. And there is one more process which is happening. What is that? The white light splits into 7 different colors. So that means dispersion is also happening there. Okay, dispersion is also happening on the first surface. And what about the second surface? Oh, there is a type of reflection happening. But this is partial internal reflection. Please understand, on the second surface, the partial internal reflection is happening. Okay, similarly, on the third surface, you can see that it is changing its medium again from water to air. So what happens? Refraction happens again. So these are the 3 things that you need to keep in your mind when you talk about rainbow formation. So this is how the rainbows are formed. So once these processes are happening right inside a water droplet, what is formed? A rainbow is formed. So it is happening across all the water droplets and creating a beautiful rainbow in the sky. Clear? And I hope everyone is clear with whatever the points we discussed in the part of rainbow formation. And now we are moving towards the summary part. Oh, what is it all about? It's all about the end of part 1, where we discuss laws of reflection, then we discuss types of reflection, image on a plane mirror, image types, and finally dispersion. So these are the basic concepts that we have learned today, and now we are diving into the next part. It's all about structure of human eye vision, types of lenses, correction of eye defects, and finally braille system. So these are the 5 topics that we are going to learn in this part. So look at this. It's all about human eye structure. Oh, this is a very complex organ, right? Yes. So without eye, we cannot see. So let's name them one by one. Cornea, pupil, iris, ciliary muscles, vitreous chamber, retina, optic nerves, lens, and aqueous body. Oh, this is a very complex organ, I guess. So let me tell you the basic functions of these parts. So the very first part is nothing but cornea. So cornea is considered as the outermost layer of the eye where the refraction takes place. Got it? Then we have iris. So iris can be found in different colors. You might have seen a lot of people with different eye colors, starting from black, brown, hazel. they have different eye colors, right? So eye colors can be different from one person to another, depends on the melanin content that they have. Okay, it's nothing but a pigment. Iris function is nothing but to control the pupil. Oh, what is pupil? Pupil is a small opening through which the light enters into our eye. Very important. Then we have lens, and lens is going to focus the objects. And we have ciliary muscles which helps to adjust the lens. It helps the lens to get adjusted at various distances. And retina. What is retina? Retina is a place where the photoreceptor cells are present. Not only that, that is a place where the images are formed. Very, very important. Then I told you that there are photoreceptors in retina. So there are mainly two types of photoreceptors. What are they? Rod cells and cone cells. So rod cells are sensitive to dim light, whereas cone cells are sensitive to bright light. Very, very important. And finally, we have to talk about optic nerves. What are these optic nerves? These can transmit electrical signals from eye to the brain. Very, very important. And now we are moving towards visual defects. So what is meant by a visual defect? Look at me, I'm wearing a spectacle here. So that means I have an eye defect. Not every person has a good vision. Some people like me can have defects like these. So we are going to talk about basic 3 types of defects. And here we are going to learn the very first one. It's nothing but myopic vision. You have to be very specific with the names. So I'm going to compare the normal vision and myopic vision here so that you will get a better understanding of it. So normal vision. Normal vision means a person has no issues. Okay, the person has no issues at all. He is perfectly fine with his vision. And look at this. For that, if the person has a normal vision, the nearby objects are very clear to him and the distant objects are also clear to him. There is no vision problem, right? So that the image forms exactly at retina. Okay, because he has no eye problem. Therefore, what happens? Image forms exactly at retina. Okay, so this is where the image is formed. But look at this one, myopic vision. Myopic vision means short-sightedness. Myopia means short-sight problem. That means the person has no problem in seeing nearby things. It's very clear. But what about the distant objects? It's very tough. Okay, it is going to be blurry. The images are going to be blurry. What about the causes? What are the basic reasons behind it? Elongated eyeball, less focal length of the eye lens. These are the basic 2 causes of it. And what about the image formation? Look at this image. Where is the image formed? Oh, not at the retina. It is in front of retina. Okay, the image has formed in front of retina. So that is what the reason we need to correct it with a concave lens. Clear? So we have to use a diverging lens so that what happens? The image can be formed on retina. Okay, if the person has myopia, image will be formed in front of retina. But if you use a concave lens, this can be making the image to be formed exactly at retina so that the person's eye problem can be corrected. Clear? Got the point? And now we are moving towards the next defect. It's nothing but hypermetropia, wrong sight. So look at the normal vision. If the person has a normal vision, the image is going to be formed exactly at retina. So the nearby objects are clear, distant objects are clear, image forms exactly at retina. But if the person has hypermetropia, nearby objects are going to be blurry. The person will not be able to see the nearby things very clearly. He is going to see the things very blurry. Okay, but distant objects can be seen very clearly. Got it? So the short eyeball size and the high focal length of the eye lens are the basic causes behind it. And image will be formed beyond retina. Look at it. It is formed beyond retina. It should be formed at retina. As this person has a defect, the image will be formed beyond retina. That is what the reason we need to use a corrective lens. Which lens has to be used? Convex lens. So convex lens is nothing but a converging lens. So that what happens? This lens can be used to correct the defect and therefore the image will be formed exactly on retina. So this is how the correction has to be done. Got the point? And now we are moving towards the next one. Presbyopia. That's the third defect. Presbyopia. Okay, so presbyopia. So when you look at the normal vision, again, the image has to be formed exactly at retina. No issues with nearby objects, no issues with distant objects. Everything is so clear, right? So image forms exactly at retina. So if the person has presbyopia, nearby objects are going to be blurry and distant objects are going to be clear, similar to hypermetropia. But the reasons are quite different here. Look at it. Inability of lens to focus due to the weakening of ciliary muscles during old age. So this is happening to old age people where they have an inability to focus due to the weakening of their ciliary muscles. So this can be corrected using a convex lens again. Clear? So I hope everyone is clear with this point. Shall we move on? And now we are going to learn the very last topic of it. It's nothing but Braille system. So what is Braille system? This is nothing but a system that has been developed for visually impaired people. So this helps them to read and write, and this has 63 patterns or characters they can simply recognize on touch. Okay, so these characters are bit raised so that they can simply touch and recognize the characters. So this is nothing but a system developed for visually impaired people. So I hope you're clear with all the points what we discussed so far. So now we are moving towards the summary part. So we discussed the structure of human eye vision, types of lenses, correction of eye defects, and finally Braille system. So I hope everyone really liked it. So that's all about today's session, and I hope everyone really liked it. And it's all about light chapter. And if you find any kind of doubts in between, please don't forget to put your doubts in the comment box. I will help you out. And this is Aishwarya Sindhu Ramachandran signing off. And let's see you in the next class. Till that, a very good night and a very good bye.